Good day, viewers. Thanks for watching. In today's class, we are going to observe mapping. We won't just observe, we're going to study mapping. What is mapping? Mapping simply means association or relation between two sets. I repeat, mapping means association Mapping simply means mapping simply means association or relation between two sets. Association or relation between two sets. And we have types of mapping. One, we have injective mapping. Let me write types of mapping for you. We have types of mapping. We have types of mapping. One is injective mapping. Two, subjective mapping. Three, bijective mapping. Four, composition of mapping. Five, constant mapping. Six, identity mapping. Seven, inverse mapping. That is inverse function. Then eight, ordered pair mapping. Ordered pair mapping. Okay. Look at the types of mappings we have. But first of all, what is mapping? If I should start giving you examples of mapping, it will fall within this injective and subjective. So that is why I decided to give you the meaning of mapping and the types of mapping. But I'm going to give you examples of this individually. Now, mathematically, how do we know injective mapping? Today in the world, we have many car producing companies, right? We have Mercedes-Benz. We have Mercedes company that produces Benz. We have Toyota that produces SUV, Camry, and all that. We have Peugeot that produced 505, right? We also have Nissan. Yes, they have their own product. We also have what? Ford that produces what? Edge. Okay. Range Rover, what's that company? They do produce Range Rover, right? Okay, now, but let's work with the not common. Let's use the word popular car producing company. Now, look at this. And we have something like this. Now, this is Um, Give me one name of Benz, you know. Ben. GLK, right? Is it Benz GLK or just GLK? GLK, right? 505, right? Camry, right? This is Mercedes, right? And this is Peugeot, right? And this is what? Toyota. Call this X, call this R, right? So we call this F of what? S tends to what? R. This is an example of injective mapping. Injective mapping is the mapping that the domain is an image of the codomain. What do I mean? We have what we call domain and what we call codomain. So this one is codomain and this one is what? Domain. The domain in the sense that this is the product of this company. Do you understand now? This is injective mapping. And another name for injective mapping is one-to-one mapping. Is what? Either you call it injective mapping or in bracket you call it one-to-one mapping. The next we have on our list is subjective mapping. We have what? Subjective mapping. I was supposed to use the circle. Here we have A, B, C, D. Okay, let's stop there. 1, 2, 3, 4, 5. Now look up. We have stops like this. A to D is how many? How many are they? 4, right? But 1 to 5, is it 4? 5 what? Digits, right? So why we call this subjective mapping is that the domain the codomain must equal to the what? Domain. As we have A to D now, A is the first letter in numeral in alphabet, right? B is the second one, right? And C is the third one. D is the what? Fourth one. That is to say that the domain must correspond to the what? Codomain. Did you understand now? This has its own question, but we are still at the introduction. We are still on the peripheral of this topic. Now, if we should call this thing X and here R, it's going to be what? F of what? When F of S tends to what? Or do you understand now? Now let's go to the bijective mapping. When we talk about bijective mapping, bijective mapping is a combination of subjective and what? Injective mapping. Bijective mapping is the combination of subjective and injective mapping. So the example of this and example of that is what we can find here. That's why we call it what? Bijective mapping. Now, number 4, composition mapping. Composition mapping. Here, let me use a diagram to explain this before we start writing. Okay, let me just, here we have f tends to x, tends to u, and we have t, and we say g tends to u, and we have x. No, and we have h. Sorry, we have h. We have h. This h now is going to be still be this s. So this is s tends to t, f tends to t, s tends to t, and this h is s tends to what? U. Let me give a diagram to explain that. What we mean by composition what? Mapping. If here is t, and here is x, and here is u, we have f here, and we have g here, and we have h here. Look at it now. Look at it now. This is what we call composition mapping. See the way they are composed. I see the way they are composed now. So look at t, look at s, look at u now. This x now, f now is s tends to what? T. S content t, and this t, this g now, u. You see the arrow and the direction. What is that on composition mapping? Now, the next is constant mapping, right? The next is constant mapping. Constant mapping. The next is constant mapping. In constant mapping, an element is assigned to contain all the elements in domain are assigned to contain one element in the codomain. In constant mapping, if not for our space, I would have written this on the board. In constant mapping, all the elements in domain are assigned to contain what? One element in the what? Codomain. What do I mean? If you have, I usually like using x and u like this. Now this x, this r, and in this x we have this x we have elements like we have elements A, B, C, D, E, and R here we have I, X, maybe R, T. Constant mapping is saying that all the elements here, because we're talking about R, right? So here, everything here is on what? On R. That is constant mapping. This is domain. And this is co-domain. So anytime you see constant mapping, it shows that all the elements in a given letter, maybe in a question, they might put y here and put x here. Another letter there, here. So all the elements in the one given, the first one given, will contain that one in the codomain. Do you understand the point now? It will be assigned to contain one element in the codomain. Next is identity mapping. Next is what? Identity mapping. That is number 6, right? Identity mapping. This is number 5, right? Okay. Identity mapping. Remind me this next one, inverse. For identity mapping, if you have F, let me use another letter now, X tends to what? Y. And X here, we have A, B, C, D. And Y here, we have A, B, C, D. Identity mapping shows that A is the mirror image of this. And this is this. This is what? D to D. This is identity mapping. It means that X is equal to Y. But in a situation whereby the domain and the codomain does not correspond, it is not what? Identity mapping. What do I mean by that? If you have that same X here, for instance, we have A, B, C, D. Here, Y. And we have maybe E, F, G, H. We have something like this, having the arrow, not identity mapping. Why? X is not equal to Y. Do you understand now? So this is for identity mapping. What's the next one? Inverse, because I cleaned it. That is number 7. Inverse function. We'll talk about the inverse function. This inverse function is also talking about the bijective, but especially when we have f raised to power minus 1. When the function is raised to power what? Minus 1. We call it what? Inverse function. And this one found application mostly in function of function. You know this relates to function of function. Hope you know. It is I'll call this in a blueprint. Foundation to function of what? Function. Now, number 8, which is the last one, right? Number 8 is ordered pair mapping. How do we know this? Anytime you find a graph, there's something we call Euclidean graph, right? EUCLIDEA, right? What do you call this? Eh? Euclidean. Anywhere you see a line on Euclidean graph, whether vertical, then it is pair to either x or y. Do you understand now? Now, you have x, comma, y. And now this x, y is pair to maybe have 3, 7. It shows that s contains 3 and y contains 7. It shows that s contains 3 and y contains what? 3, 7. For example, you know, a line passing on a straight line, you'll be given a straight line passing on a graph, you'll be given x, comma, y. And another bracket, 1, comma, 2. It shows that x contains what? 1, and y contains, that's under coordinate geometry. We also had that in position and distance, that is in physics. Do you understand now? Now, there's an example on this. Let me use the example to strike a balance here.